lecture, we are going to discuss about the vectors and the scalar quantities. Basically, this is the fifth lecture of the electrostatics because we are come with the force quantity because force is a vector quantity. Then we have to discuss about some bit of the vector quantities and how to add the vector quantities, how to find out the resultant, and how to find out their magnitude of the vector quantities. And in this lecture we are going to discuss about all these points. Okay. And vectors and the scalar quantities. And probably you know scalar quantities. Scalar quantities are the quantities which have the only the magnitude. Scalars, the quantities that have only magnitude. Simply these are known as the scalar quantities. And some of the quantities, simply the mass. You can simply say that the mass of a body is, let's suppose, the 10 kg. You simply tell the this is the known as the magnitude. And this is nothing but the unit. Probably we all know about that. And the other is the quantities, scalar vector quantities. The quantities that have magnitude as well as direction. We have to specify the direction of that. And basically, let's suppose you have a block. Let's suppose that you have a block of mass m, basically, and this is the mass m, and simply, and this is the surface on which it is putting, and the surface, and let's suppose you apply the force in this direction. Then you are specifying the force is a vector quantity because you have to also specify the magnitude. Let's suppose you apply the 10 Newton. Newton is the unit for the force. And you have to also specify it depend upon the direction on which direction you are applying the force to the object. And let's suppose you apply the force here. Let's suppose you apply the force here. You apply the force. Are you getting? It is nothing but you have to specify the direction for the force because the motion of the block, this object, is going to be decided by where we are applying the force. Okay. And basically these are the vector quantities which need to be magnitude, as this is the magnitude, and this is the direction I am specifying, where I applying the force to it. Basically these are known as the vector quantities. Here are the some of the example of the vector and the scalar quantities. Vectors and the scalar quantities. Vector quantity and distance is a scalar quantity, and velocity vector quantity, acceleration, force, weight, electric field, the all field are vector quantities. And momentum, angular momentum is also the vector quantity. Area, and sometime area can be taken as the scalar quantity and sometime vector quantities. And angular momentum, angular velocity and the angular momentum is also the part of the vector quantities, and the scalar quantities are distance, speed, mass, time, density. You basically the scalar quantity in which you do not require any direction to specify it. Similarly, time have no direction, yes. And temperature, we simply say that the room temperature is 27 degrees Celsius. We never specify the direction, yeah, thing like that. And hopefully you will get the what is scalar quantities and the vector quantities. And electric potential, all potentials are the basically scalar quantities, and electric charge, gravitational potential, volume, work, energy, power is all are the scalar quantities. Okay, let me discuss about some bit of the difference between displacement, displacement and distance. Distance. The displacement. Let's suppose I take some example to explain it. Let's suppose you move like that, and let's suppose you start from the A point and end your journey at the B point, and then the displacement, the vector displacement is the shortest distance between the end to the final point. Then we represent it by a arrow. Simply we represent it by this arrow, and we will discuss it about. This is the displacement, the shortest distance between the starting to the ending point of your journey is known as the displacement. This is the displacement vector. We simply say that because all vector are quantities are represented by the vectors, and this is the displacement vector. We will discuss more detail in the what how to represent the vectors. And the distance, let's suppose you follow the same journey. Let's suppose you follow the same journey. I will copy it. Yes. Now the distance is nothing but the total distance that you have followed to do the total distance that you have covered is the distance. The distance is nothing but it has no direction, yes, because you are just counting the total kilometer. Let's suppose you move to the move 10 kilometer, then the distance is simply written as 10 kilometer. But the displacement has a specific direction I have mentioned there, and I have mentioned here. And this is the displacement vector. We generally say that the direction for the vector, because we have to specify the direction for the vectors, is nothing but starting point to the ending point. And in we do not require any vector quantity for representing the distance, because it is total distance covered that you have covered during the journey. Okay, and let's talk about some bit of the vector velocity. Velocity is simply the velocity is displacement by time. Displacement by time. Wait a minute. Displacement by time. This is the velocity, and speed. Speed is speed is speed is nothing but distance travel in per unit time is known as the speed, and it SI unit, we simply write it as meter per second, and distance, we all know that the distance can be measured in the meter. Okay, and these are the basic things that I have explained you, where the why the displacement and the velocity, what is the difference between the displacement and the velocity, and the distance and the speed. Okay, we will move further. Represent vectors on a plane, and simply for this we are going to uh, represent the vectors. Let's suppose vectors, to represent a vector you have to represent by this arrow. We simply say that this is the magnitude of a vector. Simply it tell the magnitude value, and this is the head, and this is the tail of a vector. Okay, and this is the nothing but the representation of the vector in a plane. Vectors, let's suppose this is the vector, I represent it as a vector, and let's suppose I have to make the 2a vector, then it is nothing but it is parallel to the a vector only, but magnitude is doubling. Then I have to double its magnitude, it look like. Okay, then this represent the 2a vector. Or simply if it is magnitude is doubling, then we simply double its magnitude, because magnitude is shown by this, and simply, and magnitude is doubled, and the direction remain the same for the vector. And if this you can take this vector anywhere in the plane, and you can place here also, but this is all vectors are same. This is a vector only, here also if we place it, here also it is a vector only, a vector only, a vector only. But take care about that, you should not change the direction should be in this way only, in this direction only, and direction should be in this direction only, and this is the a vector, and this is also the a vector, but take care of magnitude and the direction should be same, then it's all are a vectors only. And this is the 2a vector, doubling the magnitude of the a, and you can take any vector in anywhere in the space. That's it. And let's suppose minus a vector, where the direction of the minus a, you have to simply uh, change the direction. Let's suppose b vector. I have, let me take the b vector. Let's suppose I have taken the b vector as in this direction, and then minus b vector is parallel to this but opposite in direction. This is known as minus b. Magnitude should be same, take care of it, and just you have to flip the vector. This is minus b vector, and this is the b vector, and we place, if it is any vector quantity, we place a vector sign, arrow sign to the that um, field, yeah, that quantity that we are observing. And this is the simple thing that and the other is, let's suppose you have a plane, and I represent it a vector, r vector, from the origin. This is the origin 0 0, and let's suppose this is the x direction, and let's suppose this is the 1, and this is the 2, and 1 and 2. And then the r vector, how we are going to represent the r vector in the plane. R vector is nothing but 2x cap 2 x cap in the x cap is the unit vector in the x direction, and 2 y cap, this is nothing but unit vector. Y cap is the unit vector in the y direction. And simply, what is the unit vector? If anyone says that find out the unit vector is nothing but r vector divided by its magnitude. And how we are going to find out the magnitude? Magnitude is nothing but simply, let's suppose I take the, for this magnitude is the coefficient of x unit vector, x coefficient is 2 and square it, and plus y vector coefficient is 2 and square it, and then you are getting the answer is 8. This is the unit, this is the magnitude for the r vector. And then the unit vector r cap then becomes simply 2x cap plus 2j cap divided by its magnitude. Magnitude is nothing but under root 8, and this is are going to be make this unit vector. In this way you can make any vector unit. Means unit vector means it has the magnitude 1. Unit mean 1, and this is simple. And then how to add the vectors? How to add the vectors? Add the vectors. Vector addition. And simply for the scalar quantity, we simply, let's suppose you have the 1 kg potato, 1 kg tomato, and we simply add these quantities. And if anyone asks you the total amount is 2 kg you are carrying out, and simply then we scalar quantities, we simply add these scalar quantities. No need to take any vector. Yes, these simple additive, we simple say that the scalar multiplication, scalar addition, we can simply do the scalar addition of these quantities. But for vector quantities we have to take care of the direction. Then let's suppose you have the vector a here. Let's suppose you have the vector a here, and let's suppose you have the vector b here. And for this you have to find out the resultant. Then what the step is? What are the steps? You have to follow the steps. Then first, because you can shift any vector in the plane anywhere, then the method is you have to cut it down and just place the vector at the head of the other vector. Okay, and I am placing that vector a as the head of the b. You have to take care of it. And then what you have to do, then the tail of the b vector and head of the a vector, we are going to simply join this tail of the other vector to the head of the a vector. Then this gives the resultant. This is the simply, this gives us the resultant. Let me take as r vector, and this is nothing but r vector representation. R vector is nothing but a vector plus b vector. We have a vector plus b vector. We have simply this is the resultant of the vector. And let's suppose we have to find out the magnitude of the magnitude. Uh, to find out the resultant magnitude, what you have to do, let us perform a simple derivation. Let's suppose you have the a vector in this direction, a vector, and let's suppose I take the b vector, because you can always shift the any vector to any position, I take the b vector at the head of the second, then I simply this vector, we know that this is the resultant, this is the resultant of these two vectors. I have to find out the magnitude for this, how much magnitude it should have, and this is the resultant, and let me take because I can always shift the b vector, I should shift the b vector at this point, at this point, at this point, and take care that magnitude and the direction should be same. Then I can place the a vector here also. This is only the a vector, b vector, and this is the a vector, and simply this is nothing but look like a parallelogram. This is the we also known as the parallelogram law of addition. Simply for finding out the diagonal of the parallelogram will give the a plus b, the resultant, to you, and simply we are going to find out the magnitude for this and how much magnitude it is having. For this I have to construct a right angle triangle. I have put the from the head of the b vector I have put the perpendicular, and this is nothing but r vector, resultant vector, and then let's suppose I take the theta angle between them, then this is only the theta angle, then the this become, if I take the magnitude b for this and magnitude a for this, I simply I represent it any vector, the magnitude of a vector is a, magnitude for b vector is representing by simple b, and r vector magnitude is represented by the r only, and for this convention let then it become b sine theta, and this become b cos theta, then just use the Pythagoras theorem to find out the r magnitude resultant hypotenuse. This is nothing but the hypotenuse, and then just hypotenuse r square is nothing but a, the base is a plus b cos theta, and a plus b cos theta, and simply we square it, base square plus perpendicular square is b sine square theta, sine we square it, and then just calculate it, a square plus b square cos square theta plus 2ab cos theta plus b square sine square theta, and then just clubbing these values, and then we get the a square 2ab cos theta, then taking out the b common, b square common, then cos square theta plus sine square theta, then it come out to be 1. Then the resultant of any vector simply become a square plus b square plus 2ab cos theta, then resultant come out to be under root of a square plus b square plus 2ab cos theta. Remember that angle, what is the theta? Theta, we have taken the angle between the two tail of the vectors a and b. Remember that the angle is between the two tails between a and b, and simply this is the resultant. And let me find out the direction. Let's suppose I take the alpha, and alpha is alpha is simply perpendicular tangent alpha. Let me take as tangent alpha. Tangent alpha is nothing but perpendicular. Perpendicular is b sine theta, and divided by base. Base is a plus b cos theta. Simply, this will give the direction of the resultant with the a vector. Simple. Going to discuss some example questions related to the vectors, and in this example uh, we have taken the vector. These are in this form. You can clearly see that this diagram, and they are in the cyclic. Yeah, they are forming the closed figure, and in this figure also these vectors are nothing but closed, making a closed shape, and they are all in the cyclic order. Yes, simply cyclic means the one vector here and then other vector, simply. And can you now tell me, let's suppose I take the vector a in this direction. This vector is a. Let's suppose I write it as a vector, and this is taken to be v vector, and the resultant would say that when the a vector is here and the other b vector is the tail of the b vector is on the head of the a, and then the resultant is nothing but tail of the other vector and the head of the other vector. Yes, we simply draw this vector as the representation of the resultant of a and b. This is in this direction. Then the resultant of a plus b vector is in this direction. But the given is the reciprocal of it. It is nothing but the given vector, the representing is minus of a plus b. If you add them, the resultant is 0. If you add them, the resultant is 0. These all three vectors, if they are forming the cyclic. Similarly, if you try to make the resultant of these two vectors, let's suppose this is the a vector, this is the b vector. The resultant is the tail of the a to the b. This is the resultant. This is nothing but a plus b vector. And if you find, let's suppose this is the d vectors, this is the c and d vectors, and then the resultant is nothing but the tail of the c vector from the head of the other vector. This is c plus d. If you find out the resultant, they are equal and opposite in the direction. Basically, they also cancel out. Then the result is the vectors with the arrow pointing in the same sense, forming the closed loop polygon, add up to give the 0. They all add up to give the 0.